Welcome guys, it's happy to have you on board, and if it's your first time, consider subscribing. There's great content on the way, and hit the bell notification so that you don't miss it. In this video, we're gonna review the new features available in ES 2018. This will probably be the 7th edition of ECMAScript. ES 2015 is the largest upgrade to JavaScript since its creation. But now, ES 2018 adds many new modern features to JavaScript that make JavaScript more powerful and modern than ever before. The language has rest or spread properties, asynchronous iteration, Promise.prototype.finally, template literals, and regular expression related features. Before we dive in, let's review some of JavaScript's past. In 1995, there was something called the browser wars. Netscape and Microsoft were going head to head, rapidly expanding their web browser's capabilities and features. JavaScript was developed in just 10 days by Brendan Eich at Netscape. Its primary goal was to be lightweight interpreted language for non-programmers. To keep up, Microsoft later adopted the language, calling their version JScript. By 1997, JavaScript was in every browser and used by millions. The specifications was then standardized by an international standard organization, ECMA International, because Netscape owned the name JavaScript. Netscape and Microsoft agreed upon the name ECMAScript. ECMAScript and JavaScript are the same thing, and you'll hear them used interchangeably. By the end of 1999, ECMAScript 3 was standardized. It introduced things like regular expression and exception handling. Then, in the late 2009, ECMAScript 5 introduced a number of useful features to the language. This version made JSON a first-class citizen with the addition of several methods that made use of JSON a lot easier. With the early release of ES 2015, which is the latest upgrade to JavaScript since its creation, the language has new data type, improved utility function, and features to better define the scope of your code block. Most importantly, JavaScript is the only programming language native in the web browser. That's the main reason it's become such a commonly used language. It's everywhere. JavaScript is changing, and as developers, we need to adapt to the existing changes offered in ES 2018. Many browsers still haven't adopted most, if not all, of ES 2018 feature. Most web browsers have not yet implemented the ES 2018 features. In order to follow along this video, make sure you have updated your browser to the latest version, and I prefer you use Chrome. And the material in this course assume that you have the basic understanding of ES 2015 and JavaScript. And if you want to brush up on JavaScript, you can check out our previous video. I'll leave a link to that in the description below. Next, we'll start off by learning the rest or spread properties. ECMAScript 2015 introduced the rest or spread properties for arrays. So let's first try this out in our browser. We can head over to the console on Google Chrome by right-clicking and head over to the inspect. Then we can choose console from there, or we can use the keyboard shortcut Ctrl+Shift+J on Windows and Linux and Command+Option+J on Mac. Now let's create a constant called primes. It contains an array of prime number. Let those numbers be 2, 3, 5, 7 and 11. Then we are going to declare a constant of an array containing first, second and rest. Note, before writing the rest, it is followed by 3 dots. These dots signify the rest property. Then we assign this array to prime. Now let's console log each one and see what we get. So at the very beginning, we console log first. We only get 2. Then we console log the second and it returns 3 as expected. Now can you guess what happens when we console log rest? If you guessed we will get the remaining array elements, then you're right. The console returns 5, 7 and 11. Now let's try out the spread elements on an array list. Now we can create a prime copy of type constant and assign an array containing first, second and the rest. Now let's try the spread element for array literals. Now we will create a prime copy of the type constant and assign an array containing first, second and the rest. Next, when we console log the prime copy, we get all the elements in the array like before. Pretty sleek, right? The ES 2018 expanded this concept of rest or spread properties to the object as well. Now let's try out that. I will create a constant called dude that has a name object with the value Edmond. Let his age be 30 and his role be a front-end developer. Now let's assign the name and detail object to the previously declared constant called dude. Let's console log the name and it gives Edmond. Well, that's as expected. Now let's try out the same thing with details as well. Once we console log the details, we can see that we get the age and the role object. Cool, right? Now let's try out the spread properties of the object literal. I will once again create the object called details that has the age and the role object with respective values as before. Along with that, I have my dude constant. This dude has the name set to Edmond and the details which is followed by 3 dots. Let's console log this and see what is the result of our operation. All the object name, age and the role as expected. One thing we need to remember is that the spread properties offer a more elegant alternative to object.assign in many situations, as you can see from here. However, there are some substantial difference in how spread handles a setter. First, object.assign triggers a setter. Spread doesn't. And second, object.assigns creating its own properties via inherited read-only properties. But the spread operation does not. I hope you are able to follow along this. If you still have any doubts, you can always use the comment section or you can follow me on Quora and ask your doubts there. Then let's learn about asynchronous iteration. Introduced in ES 2015, the iterator interface returns an object with value and done keys via the next interface. It is possible to use it with iterables that are known as ahead of time. The asynchronous iteration allows you to replicate the same functionality for asynchronous operation and return the promise for a value and done pair. Let's create a function called example. Then we'll create a constant called array of fetch promises. This contains an array that will fetch some data from github.com. You can find the code to this in the description below. I will first show you how this works in case of a regular iterator. Then we'll move on to the asynchronous iterator. In case of a regular iterator, it logs a promise as you can see here. But for the same code, if you use an asynchronous iterator, it logs the response. The only difference in the code is we use the await after the for in the asynchronous case. Now let's create our own async iterator. Just as you can use generator to create iterator factories, you can use async generator to create async iterator factories. Async generates a mixture of async function and generators. Let's say we wanted to create an iterator that returned a random number, but those random numbers came from a web service. So let's get coding then. We will create the async function called async random numbers. Note the star that follows the function. Next, we'll create a constant called URL and set the predefined URL. You can always find the code in the description below. Next, we set while true tells us that it keeps running the condition as long as this is true. Then I fetch the response from the URL and I convert this response into a text. Then I yield a random number. Note, this iterator doesn't have a natural end. It will keep on fetching the numbers. Thankfully, you can use the break to stop it. So we again create our favorite example function. Then we can console log the number and tell if the number is greater than 0.95, then break. Cool. So this loop will end if it encounters a value greater than 0.95. Hope you found this example useful. If you have any doubts in this example, please do hit me up in the comment section below. Next, let's learn about Promise.prototype.finally. The Promise.prototype.finally is enabled by default in the V8 version 6.3.165 and higher and Chrome 63 and higher. It allows registering a callback to be invoked when a promise is settled, that is either fulfilled or rejected. A number of promise libraries have an implementation of the useful finally method. Bluebird, Q, and When are some examples. So let's dig in and implement Promise.prototype.finally here. First, we fetch some data from GitHub. You can find all of our codes in the description below. Then we take the JSON response. Next, we console log the data, catch error if any, and finally log out the screen telling all fetched. Great job, guys. Moving on, we have template literals. Introduced in ES 2015, template literals come with some restriction on escape sequence. This year version of the language solves all the blockers. The proposed solution is to set the cooked value to undefined for template value that contains illegal escape sequence, as you can see here. The raw value is still accessible via the .raw, so embedded DLS that might contain the undefined cooked values can just use the raw string. At last we'll learn about regular expression. In total we have 4 regular expression related proposal made in ES 2018. The .all flag for regular expression named capture group, regular expression look behind assertion, regular expression Unicode property escape. Let's take a closer look at all of these, shall we? Starting off with the .all flag for regular expression. In regular expression pattern, the dot matches any character, but it is getting a little bit problematic with astral and line terminator characters. The need for matching any character without restoring to cryptic workaround is very common. Other languages like Java, C#, Perl, or PHP have gotten an implementation of this functionality. Now it is coming to JavaScript under the S flag. Let's take a closer look at an example. Here in the first case it written false because there are two dot operations and the compiler assumes both of them are line terminator. Hence it returns the boolean answer false. In the next case we have an S which stands for .all that tells that this is used to match any character. Hence the statement turns out to be true. The console logs out true. Simple, right? Second, we will talk about regular expression named capture group. Number captured group refer to a part of the string matched by a regular expression. It works, but it can get a little bit difficult to read and refactor. We have named capture group to the reuse. I create a constant called RE which holds the year, month and date format. Next we'll create a variable called result which holds the date. Now see what happens. I can console log the output by either typing result groups year or result groups month and result groups day, or I can even choose result of 0, result of 1, result of 2 and result of 3. It's pretty sleek, right? Next, it's time to talk about regular expression look behind assertion. Currently, ECMAScript regular expression has look ahead assertion that checks a string in a forward direction. It is missing a backward check though. This proposal adds this feature to the language via the question mark, lesser than or equal to followed by the 3 dots, and return the result without capturing a checked string. As you can see in this example below, we have a currency that is matched against an expression. Don't freak out, I will explain how it all works out. With a look behind assertion, it captures the group that are numbered left to right. In this example, the expression is matched against the string 1053. Match of 1 would be 1 and match of 2 would be 053. Within a back reference, it is also possible to refer to the capture group that have already been evaluated. That is, the group that has to be on the right of the back reference. For example, this expression would not be a very useful regular expression as \1 cannot be resolved and would match against an empty string. Instead, to look for two copies of the same letter preceding the content, one would write the expression. Just as a note, I want to let you know, analogous to the negative look ahead assertion, well, this expression long present in ECMAScript regular expression. This proposal includes a negative look behind assertion as well. Coming to the last topic, that is regular expression Unicode property escapes. This is a fairly simple topic. Currently, there is no way to access Unicode character properties natively in JavaScript regular expression. This proposal adds Unicode property escape via the \p as you can see here. Unicode property escapes are a new type of escape sequence available in regular expressions that have the U flag set. So here is the simple example. I have a constant named regular expression Greek symbol which is set to a Unicode escape property and the script is set to Greek. Then I test the above constant by passing the pi symbol. Since it is a valid Greek symbol, it returns true. Awesome, right? As you can see, ES2018 is just the beginning of new era of modern JavaScript. We will see annual releases which will push the language forward in an amazing way. Even though today's web browsers are adopting the new features rapidly, we still need to be cautious with how we implement them in our code. Be sure to check out the description below for codes and to read more about ES 2018 specs and features. Looking back, we have come a long way. Now you have the basic understanding of all the new features that are available to you in ES 2018 so that you can adopt these features in your code. You can always show your support by liking, sharing and subscribing or by heading over to patreon.com/team CodeBig. If you still have any doubts, you can always comment below or ask us out on Quora or join the discussion at Slack or share it on our subreddit. Thanks guys, dream big and code big.